when normal chemical reactions happen, you have molecules that need to react. Sometimes they're joined together, sometimes they're broken apart. Here we have two simple sugar molecules that normally bounce around in a solution until they hit at just the right angle with just the right velocity and energy so that they can form a bond. Let's say these would be forming a disaccharide. So here they go. Oh, they just missed. This time, I'm sure they're going to, oh man, this time, maybe this time, oh, darn it. They just keep going until they hit at just the right angle. Doesn't happen very fast. All of that energy of them bouncing around and the energy that's involved with heating them and making them move, that's called activation energy. Enzymes make things a little bit easier. Here we have an enzyme, and this part of the enzyme right here is called the active site. It's the site on the enzyme that is active in the reaction. And the enzyme lowers the amount of activation energy a couple of ways. One, it's going to attract these two things. These sugars, we're going to call them substrates. Substrates are the reactants in an enzyme catalyzed reaction. So this enzyme works on these substrates, and it's going to attract this part of the substrate molecule so that it pulls them in closer together. That's one way that it reduces activation energy. Second thing is that when it pulls them together, it's going to pull them at just the right angle so that they can actually be oriented to form the bond. Okay, the reaction happens, the bond gets formed, and then the products get released. Okay, so there's two specific ways that the enzyme reduced activation energy. What do we notice about the enzyme? It is not changed. Once it releases the products, it is the original same shape that it was before. The active site has the same complementary shape as the substrates, and it can pull them in. Why are they specific? Well, here we have two enzymes. This one we'll call Mr. Green. This one we'll call Mrs. Yellow, just to make it simple. Mr. Green would like to catalyze a reaction where he takes a double sugar, breaks it apart to make two monosaccharides. Do you think he can do it? Let's see. Oh, poor Mr. Green. It doesn't work because the substrate does not fit into the active site. However, there is an enzyme that is specific to that reaction. Mrs. Yellow is very happy because she can catalyze this reaction. She can bond to those sugars, and in this case, she would break the bonds and release the products. Even though this looks exactly like the enzyme on the last screen, this is a different enzyme because the first enzyme we looked at formed a bond between two monosaccharides. This one is breaking a bond between a disaccharide to release products. That's different enzymes doing different things. However, Mr. Green, don't look so blue. You have your own reaction that you can catalyze because each enzyme is specific. What makes them specific is the shape of their active site. So Mr. Green has an active site that will attract these two substrates, pull them into place, form the bond, and then release the product. In this case, maybe it's sucrose. Sometimes enzymes don't just bond products and then release them. Here we have an enzyme. It's going to draw in some simple sugars. It's going to form a bond, and then as it releases the products, it's not really going to release them. It's going to shift them over and pull in the next subunit. And it forms a bond there. It will then shift everything over, pull in the next substrate, and form a bond. And it's just going to continue to keep doing this to make big, long molecules. Really good sound effects on this video. So this could happen with, maybe it's inside of a plant cell that has made a lot of sugars and now it's building starch. The polymer would be the starch molecule. The sugars would be glucose. Maybe it's inside of a cell that is making DNA. So these would be nucleotides being linked together. And this would be like a DNA polymerase building the long chain of nucleic acids. Or maybe this is a protein that's being assembled at the ribosome, and these would be amino acids being brought in and linked together to make the protein molecule. Any of those things is possible. That's how polymers get built inside living things, and it happens very, very quickly. Last thing, if we have an enzyme and it works, draws in the substrate, bonds them together, releases products. If you've ever taken crayons and left them in a car on a hot summer day, When you come back in an hour, they don't really look like crayons anymore. They look like puddles of crayon. The same thing can happen with enzymes. If it gets way too hot, it's actually going to change the shape of the active site. It's going to melt and what we call denature the enzymes. Denaturation means taking away the natural shape of the molecule. And so because it's denatured, what does that mean for the substrates? They cannot fit into the active site. The active site is gone. The enzyme does not work anymore. What would happen is this enzyme would be recognized by the body as not working. It would be chopped up into its constituent amino acids, because enzymes are proteins, and then the amino acids will be reused to build something else, some other protein that's needed. Now, what do cold temperatures do? Because that explains really hot temperatures. Remember, when these things were all just bouncing around at the right angle, well, the hotter you get it, the faster they're going to move. The more collisions are going to happen. The colder you make it, the slower it's going to get, until, if it freezes, everything just stops moving and just sits there and vibrates. So cold temperatures slow down chemical reactions because there's less collisions between chemicals. Hot temperatures increase the rate of chemical reactions until you get to the point where the enzymes get denatured because the molecules are just overheated. pH range can also have a similar effect to hot temperatures. If the pH gets too high or too low, it can actually denature the enzymes outside of whatever the normal range is for that enzyme. Hopefully that gives you a bit of an idea of how enzymes work. It's a good animation. You could always return to this and watch this again if you go to the website that's at the top of the page.